Hi, this is a quick pyNITA run from source workflow video just to get a sense of what I'll be talking about and what the software is supposed to do. So first of all, you can see I've cloned the repo here, and in the README it says you need to move some files around to do the to run Docker, to run from Docker. So that's in the installation, not source, Docker Windows, grab all of these and move them back to the root, and then run command as administrator. Okay, and then I would have to run once this prerequisites.bat for the Xming installation. So that's important, but I've already done that. So I'll go right to Docker run Windows. So this software is for time series of remote sensing imagery, like Landsat is a satellite that's visited same point over the Earth every 16 days since 1984. And so that's most of the data that we use. And to look at how each pixel has changed over time based on some index of vegetation cover. So first, I will set a working directory for where the data are. And there's a demo data set that comes with the install right here, demo data set. Submit that. Select a default user configuration file, which is in the demo data set. Just take the straight user configs will be the one that comes with it. Here's all the parameters that one can adjust. I'm not going to do any of that right now. Step 2 is where you can look at how your parameter set actually fits trajectories at some number of known pixels. So the user would create a point file, a spatial point file that would then get turned into a CSV of places that they knew well. So this is an oil palm plantation in Indonesia that one of our collaborators knew well enough. So it's the points file, submit, and now we can look at the information about each of those points. For example, one is a swamp, network of canals, etc., just to remind you what you're looking at. And if I wanted to look at the 1st through the 9th points, I can do that. And so you're seeing here, this is 9 pixels, basically. So the first one is a good example where you've got, this is vegetation index, so lots of vegetation from 1990 or so out to 2015, and then some kind of disturbance, meaning they cleared the land to plant oil palm. And so the vegetation was lost, but then it was regained quickly because the oil palms grew back. And so this shows you how well the trajectory fits this data over time. And so a lot of this noise is attributable to poor atmospheric conditions like light cloud cover and such. So you'd look at this and then you'd go back to step 1 and make some adjustments to your parameters. I won't do that right now. Step 3 is the production step. So you'd actually bring in the images. So you've got NBR as a normalized burn ratio. That's just a type of vegetation index based on spectral information. And then it comes with a dates file that tells you when all the images were taken for this image. If you want to, if you're not ready to run the whole thing, you can draw out a subset and just process that and look at the results. But you can't save off those results. Clear that for now. I'll just run the whole thing. You can specify your number of processors. And then step 4 is the output call them the metric images, actually the things you want to know about your landscape. So for example, if I want to look at the disturbance date, so when were all these oil palm plantations put in, you can see we now have a map of dates. And over on the left, there's nothing there because there was no disturbances. That's all just intact primary forest. Over here, there was disturbances at different dates from 2014 to 2016. And then if I think like, oh, what's going on at this pixel? I can just click and it will show me the actual pixel history or trajectory that we created based on our parameter set, which may inform a a trip back to make some more adjustments back in step one. You can also just, for example, see the change. This is not based on disturbance. This is just how did that pixel change over time? Did it increase? So this is just slight increase in vegetation cover based on natural growth, for example. And so then the user could save this stuff off. That's all I'll show for right now.